Alright, so today this week, we're going to be talking about multiplying and dividing rational functions. Remember, a rational function is a polynomial over a polynomial. Specifically, today we're going to be focusing on just multiplying fractions, rational fractions, and then tomorrow we'll be focusing on dividing rational fractions. Hopefully I sound a lot better. My husband gave me his work headset to record this video, so the audio sounds a little bit better. So let's get started on number 1. It wants me to simplify. I don't know why when I print from Word, my home printer does not print out all the numbers, so I had to write in 12. But what I want to do on number 1 is I first want to factor my numerator and denominator. So my first step is to factor numerator and denominator. So I'm looking for, on my numerator, what multiplies to negative 12 and adds to negative 4. It's going to be negative 6 and positive 2. And then we'll do the same thing for my denominator. So what multiplies to negative 4 and adds to 0? It's going to be x minus 2 and x plus 2. Or you could remember, I'm going to write these in green. We have some special factoring cases. Special factoring cases. This pen does not like me. So, we have the example where it's a squared minus b squared. This is called difference of squares. It factors out to a minus b, a plus b. This is something we learned last semester. So then what I want to do once I factor out from my first step, my second step is to cancel out any repeated pieces. So if I take a look on my top and bottom for this one, I have an x plus 2 on the top and bottom. So I cancel that out. Then my third step is to rewrite the fraction. So I'm going to have x minus 6 over x minus 2. And then what I need to say is, because I canceled out this, I need to say what my domain can add. So rewrite the fraction and identify domain restrictions. So what I do to do that is I'm going to take the value I canceled out, x plus 2, and set it not equal to 0. Like that. And then I solve for x. So I get x can't equal negative 2. Because that's a hole in my graph. I just simplified the fraction to make it look nicer. Okay. So then I want to go ahead and do the same thing for number 2. Instead of, well, not the same thing. It's kind of the same. I can multiply first, or I can cancel out first. Since I just have x's and y's and I don't have polynomials, I'm just going to multiply across first and then cancel out. So I have 8 times 7 on the top, which gives me 56. I have x cubed and x to the 4th. So remember, here I add my exponents. Then I have y and y cubed. This y has a secret 1, so it's going to be y to the 4th. On the denominator, I have 2 times 4, which is 8. X, no x, so I just write an x. And then I have y squared and a single y, so y cubed. Then what I want to do from here is I want to go ahead and simplify if possible. So I'm going to start with my whole numbers. So 56, oops, I covered up way too much. 56 and 8, so 56 divided by 8 is 7. And then I want to subtract my exponents, so I'm going to go write this one in red. I have 7 on top, 1 on the bottom. I subtract 1 from 7, which gives me 6. It's a positive number, so it goes on top of my fraction if I'm going to have one. Then I do the same thing for y. 4 minus 3 gives me 1, so y just goes on top. number 3, this is one where I want to factor first. So I can also factor out the GCF. That's what I'm going to do for my numerator part. So I'm just going to take out 3x. 3x divided by 3x is 1. 3x squared divided by 3x is just x. On the bottom of this one, I'm looking for what multiplies to negative 5 and adds to positive 4. So I have negative 1 and positive 5. Then over here, I have, hopefully that cough did not sound as bad as it normally does. Over here, I have negative 30, so I want to look for what multiplies to negative 30 and adds to positive 1. It's going to be negative 5, positive 6. On the bottom, I have 3x. So one thing I want to point out is for all of these, except for the 1 minus x right here, I have the x first. In order to rewrite this, I can rewrite it as a negative outside the parentheses, x minus 1. So that changes the signs around. So what I'm going to do is right below here, I'm going to rewrite this whole thing and changing this to this. What I did was I divided out a negative. So I divided out the negative to turn this to positive, and dividing out a negative turned that to negative. So now it's going to be negative 3x, and I can rewrite this as x minus 1 over x minus 1, x plus 5, x minus 5, x plus 6, over 3x. And then, since I'm multiplying, I can cancel out. Sorry about that. Working from home, I didn't realize I could get calls on my computer in the middle of recording, so. Where was I at? Oh, so I was saying I want to cancel out things that are on both the top and bottom. So I have x minus 1 on the top and bottom. It doesn't matter which fraction they're on as long as it's on the top and bottom. And then I have 3x and 3x. This negative stays. So I'm going to go ahead and rewrite the negative. These things weren't crossed out, so they stay on top. And then I just have x plus 5 on the bottom. I can do the same thing for number 4, even though only one of them is a fraction. When I go ahead, this is going to be over 1. So just note that the polynomial goes on the top of the fraction. I will factor. Before I do, I want to point out I'm going to have a special factoring case on the bottom. It is going to be difference of cubes. So in this instance, it's subtraction. I don't know why I said it that way. Difference always means subtraction. It's a cubed minus b cubed. This one gets rewritten as a minus b. And instead of parentheses, a squared, that's 10 plus ab plus b squared. Okay, so notice this one is the same sign as there. This one is opposite that sign. I am going to factor now. So I have x plus 2 on the top of my first fraction. Nothing changes there. On the bottom, my x cubed is by a cubed, and 27, the cube root of it, is 3. So I'm going to go rewrite as x minus 3 in my first set. And then I'm going to have x squared. X times 3 is 3x. And 3 squared is 9. I'm going to rewrite the second. So over here I'm looking for what multiplies to 9 and adds to 3. I could try looking for it, but if I notice that's exactly what I have in the denominator of my first one. So I'm just going to rewrite this off to the side over here. And then I can cancel out repeated things. So, repeated, repeated. I don't really care about a 1 because anything multiplied by 1 is itself. So my final answer here is x plus 2 over x minus 3. Oh, I forgot to find where my x can't be on number 3. So for this one, this is my answer, because this will give me an imaginary answer when I set it equal to 0 and solve. On number 3, I forgot to solve up here. So I need to do 3x can't equal 0, and x minus 1 can't equal 0. So divide by 3, x can't equal 0. Over here I add 1. X can't equal 1. So what I want you guys to do right now is pause the video, take a few minutes to work on the 4 on the back, and then come back to the video once you have solved those ones out, and I will go through and work through those ones too. Okay, so what I'm going to do on number 5 is just simplify. So I'm going to find what multiplies to negative 12 and adds to negative 1. It's going to be negative 4, positive 3. On the bottom, it's going to be a difference of squares. So it's going to be x minus 3, x plus 3. I want to look to see what I can cancel out. I can cancel out my 2 plus 3's. So I'm left with x minus 4 over x minus 3. I want to solve for what it can't be on the denominator. So I'm going to have x plus 3 can't equal 0. Get x alone. X can't equal negative 3. Ugly 3. Right. Okay. On number 6, since these are just variables and not polynomials, I am just going to multiply straight across. 6 times 9 is 54. I have x squared, x to the 5th, so I add those to get x to the 7th. I have y squared, that adds to 3. On the bottom, I have 3 times 2, which gives me 6. Only one x, so I just rewrite that. Y cubed and y, so I add that to get y to the 4th. I want to rewrite my exponents. Or not rewrite my exponents, write my hidden exponents. Then I want to focus on simplifying. So I want to do 54 divided by 6, which gives me 9. I get x to the 6th. I didn't even say y. I subtracted 1 from 7. On my y's, I'm going to subtract 4 from 3. So 3 minus 4 gives me negative 1. Negative 1 means it goes on the bottom of my fraction, and I rewrite it as a positive exponent. Since it's 1, I don't have to write the exponent. So that is my answer. Number 7, I need to factor before I can solve. Notice 5x and 5x squared have 5x in common. I can actually take out negative 5x to begin with, since I know I want this piece to be positive. So then I'm going to get negative 1 plus x. It looks a little weird, but it is just opposite, because the sign is positive now. It's just written in the opposite order of what we typically write. And then on the denominator, I'm looking for what multiplies to positive 3 and adds to negative 4. That's going to be negative 3, negative 1. On my second fraction, I'm looking for what multiplies to positive 6 and adds to negative 5. It's going to be negative 3, negative 2. Denominator stays the same. So I want to look at what I can cancel out. I have 5x cancels out. This one, positive x, negative 1, negative 1. Those two cancel out. And I also have negative 3 and negative 3. Those two cancel out. So I am left with, on my top, I have this negative. And then I have x minus 2. I have nothing on my bottom. Since I just have a negative outside of parentheses, I actually probably want to distribute this. So I get negative x plus 2. And what I also want to do before I move on is everything that was on the denominator that I canceled out, I gotta find out where I can't plug in those values. So I have x minus 3 can't equal 0, x minus 1 can't equal 0, 5x can't equal 0. Add 3, I get x can't equal 3. Add 1, x can't equal 1. Divide by 5, x can't equal 5. So over here I want to write x can't equal 3, x can't equal 1, x can't equal 5, and I shouldn't have boxed off my answer. This is still part of my answer. Moving on. Number 8, I want to factor. This one is using sum of cubes, which is similar to difference of cubes. So in this situation, I have a squared plus b squared. And then in parentheses, I have a plus b. Then it's going to be a squared. This sign is opposite what I had over here. So it's going to be minus ab plus b squared. And I should have a parenthesis there. Look, what's missing. So I'm going to go ahead and factor. On the top, nothing needs to be factored. It's just x minus 7. On the bottom, x is my a. The cube root of 8 is 2. So that's going to be my b value. And I have x plus 2. And then I plug into here. So x squared, 2, or x times 2 is 2x. And then 2 squared is 4. Then I have over here x squared minus 2x. That looks gross. Divided by 1, because there's no denominator. Then what I want to do is I want to go ahead and cancel out any repeated things. I have this repeated and this repeated. And then I'm just left with x minus 7 over x plus 2. And that is my answer. For this one, the reason this doesn't work is since I can't simplify this anymore, if I was going to go graph it or actually solve it, it wouldn't cross the x-axis. Let me actually graph this for you to show you what I'm talking about. X squared minus 2x plus 4. So here it is graphing. Notice it doesn't cross the x-axis, so it doesn't have any x values that are affected by this. So if I have a polynomial that can't simplify anymore, and I cancel it out, there's nothing I have to solve for. One last thing I wanted to say before I finish this video is I now have office hours on Canvas, and I was going to show you. Sorry about the viewing window. But so I think I have 4 time slots in the mornings and 4 in the afternoons. So what you do is on the sidebar, you scroll down until you see Cisco WebEx. I think it looks pretty similar for you from this point. Wait for it to load. Okay. And then what it's going to have is it's going to have my appointment times. I have some meetings next week, so I've taken off the meetings I have, so you can't schedule those. But you can go ahead and schedule these. I know there are some time slots in the morning on Tuesday and Thursday that have already been selected, so you might not see those options. But anyways, you go through and you click whichever one you want. It's a half-an-hour session. I think you log into Canvas, and then, or it sends you an email link to get the video upload, and then you can meet for half an hour to discuss your work, or even just talk if you just miss me and need someone to talk to. So I totally get that. My cat does not like having me home, so I don't mind talking to people. Anyways, so that's how you set up a tutorial session. So let me know if you need any help setting that up, or if you have any questions about this video or anything else math related. Thank you.